Function of bounded variation. Let f be a mapping of closed interval a comma b into r to the power p, and let p is equal to x0 is equal to a comma x1 and so on xn is equal to b be an partition of closed interval a comma b. Let delta fr is equal to fxr minus fxr minus 1. Define v closed interval a comma b p comma f is equal to summation r is equal to n mod summation fr. P closed interval a comma b comma f is equal to supremum b closed interval a comma b comma p comma f. So v uh, closed interval a comma b p comma f is total variation of f on a comma b closed interval. The function f is said to be bounded variation on closed interval a comma b if and only if v closed interval a comma b comma f is less than infinity. Now let there's an example. Let a function f defined on closed interval a comma b, then partition p is equal to a is equal to x naught x1 and so on xn is equal to b. Then v f comma p is equal to summation r is equal to 1 to n del f r summation runs over r is equal to 1 to n mod f x r minus f x r minus 1 is called the variation of f corresponding to p. Thus, f has bounded variation on closed interval a comma b. v p comma f v f comma p is less than equal to k for all p belongs to p closed interval a comma b. So v f comma closed interval a comma b is equal to supremum v f comma p such that p belongs to p closed interval a comma b. v f comma closed interval a comma b is equal to v f comma closed interval a comma c plus v f comma closed interval c comma b. So vx is equal to v f closed interval a comma x such that x belongs to closed interval a comma b. Now there is a theorem: a bounded monotonic function is a function of bounded variation. Now इसका प्रूफ देखते हैं. Let f such that let f be a mapping a comma b into r be a monotonic function. Let p is equal to a is equal to x0 comma x1 and so on xn is equal to b be a partition of closed interval a comma b. Then v f comma p is equal to summation r is equal to n r is equal to 1 to n mod f x r minus f x r minus 1. जिसको हमने क्वेश्चन नंबर 1 नाम दिया. Now case second, let f is monotonic increasing function, so x1 is less than x2, or it can be written as f x1 is less than f x2. इसको रीअरेंज करके लिखेंगे which implies that f x1 minus f x2 is less than 0, or we can write it f x2 minus f x1 is greater than 0. Now mod fx2 minus fx1 is implies that fx2 minus fx1. Now from equation number 1, v f comma p is equal to summation runs over r is equal to 1 to n mod f xr minus f xr minus 1. Now f x1 minus f x0 plus fx2 minus fx1 plus so on plus fxn minus fxn minus 1, or it can be written as fxn minus fx0. So यहाँ पे xn is fb and fx0 is equal to fa, so fb minus fa. v fp is equal to fb mod fb minus fa, as a is less than b, so fa is less than fb, which is equation number a. Now, case second. When f is monotonic decreasing function, x1 is greater than x2. So fx1 is greater than fx2, or it can be written as fx1 minus fx2 is greater than 0. So Vf comma P is equal to summation mode fxr minus 1 minus fxr. So fx0 minus fx1 plus fx1 minus fx2 plus so on plus fxn minus 1 minus fxn, or it can be written as fx0 minus fxn. So Vf comma P is equal to fa minus fp. A is greater than B. FA is greater than FB, which is equation number B. So FA minus FB is greater than 0. VFB is equal to mod FA minus FB by equation number A and B. So FA is less than FB and FA is greater than FB. Then VF comma P is equal to finite. So F is bounded variation. Now, there is another example or theorem. Let f be a monotonic and bounded on closed interval a comma b. Then f is of bounded variation on closed interval a comma b, and vf is equal to mod fb minus fa. इसका प्रूफ देखते हैं. Let f be a monotonically non decreasing on closed interval a comma b. Then for any partition p is equal to a is equal to x0 comma x1 and so on, xn is equal to b. Now summation runs over r is equal to 1 to n fxr minus fxr minus 1 is equal to summation runs over r is equal to 1 to n mod fxr minus fxr minus 1. Now fxn minus fx0, which is equal to fb minus fa. Therefore, vf is equal to supremum summation r is equal to 1 to n mod fxr minus fxr minus 1, and vf is equal to mod fb minus fa. There is another theorem. If f is bounded variation on closed interval a comma b, then show that it is a bounded on closed interval a comma b. So f is bounded variation, there exists k is greater than 0 such that v f comma p is less than equal to k. So v f comma closed interval a comma b is less than equal to m. Now mod fx minus fa is less than equal to vf comma closed interval a comma b, which is less than equal to m for all x belongs to a comma b. Mod fx minus fa is less than equal to m is implies that fx mod fx minus mod fa is less than m. So mod fx is less than m plus mod fa for all x belongs to uh, closed interval a comma b. Hence f is bounded on closed interval a comma b, and mod fx minus mod fa is less than equal to mod fx minus fa is less than equal to m.